I've got a 10 amp panel meter here. There's a bag of accessories, nuts and washers. Here's the meter itself. There are 4 mounting studs back here. They look like number 3s, but I'm not sure. And here are 2 meter connection studs. This meter is 0 to 10 amps, and there's no external shunt required, which means the full 10 amps enters and leaves. Well, this is a positive connection. Full 10 amps enters the case of the meter. Now, I'm sure that the little wires that form the arsenal of movement don't handle the 10 amps. So we'll take this case, we'll take this front off and see what it looks like. Now, when you put this back on, there's this little U-shaped yoke down here. Moving that changes the 0 setting. Can you see that? So I'm going to put it right in the middle. Forget about where the needle is. And I'm going to take the little stud that sticks down here. I'm going to put it right in the middle. The stud is at the bottom of the case now. It's hard to see. I don't know whether you'll see that. Well, it actually moves around a little bit. Anyway, when we snap this back on, this little actuating stud has to fit inside the loop. And take out these screws. Now, this requires not damaging the meter movement. The meter needle is supported on bearings and connected to the terminals with red wires. There's one here and one exits the back of the meter movement. We can see in the terminals they're bridged by a thick jumper. Then there's a little resistor in series with the movement itself. In any event, the 10 amps, the bulk of the 10 amps, flows through this wire, or shunt. And a little bit flows up the red wire through these little fine windings. They're really fine windings. Here. And then leaves and flows back through the resistor. I'm going to remove that shunt here. So I'm going to remove the remnants with a soldering iron. It certainly wasn't very well soldered to the stud. I may just take both of them off. Now we have to be careful because this round thing inside the shield is a very powerful magnet, so stuff will stick to it. We don't want stuff to stick to it. Oh, that's nice. So what I've done is broken the shunt. Of course, I actually broke the solder joints. I soldered the end of the resistor back on. Okay, so now I have no shunt. The next thing I'm going to do is going to mark the front of the scale of the meter. Now the reason I chose a 0 to 10 amp meter is because I wanted to reconfigure it as a 0 to 1 amp meter. So I got these things on Amazon, and they're pens with different diameters. I think I'll try the 0.05 millimeter one. I wish I had one of my draftsmen from 20 years ago do it, but I put decimal points in front of all the figures. Take the meter movement, slide the scale back on. Turn the screw backwards till it fits in the slot. That way we don't cut a new thread each time. Okay. Reassemble the meter. Okay. See, I can move that needle, and the idea is to make it read 0. And it may change from vertical to horizontal. This one doesn't, which is nice. So there we have a 0 to 1 amp meter. We're not done yet because I've taken a shunt out. What I'm going to do is put 2 flat washers and a nut on each meter stud. Now this was advertised as a 75 millivolt amp meter. Well, what the hell does that mean? It means whenever 10 amps flows through the meter. It would be 75 millivolts. 75 millivolts would be dropped across the terminals. It's nichrome wire, type 80, 20 AWG. Now I did some calculations and I said, what if 1 amp flowed through a piece of wire? What would it, in order to develop 0.075 volts in that piece of wire, what would the resistance be? Well, Ohm's law says that 1 amp flowing through 0.075 ohms will cause a 75 millivolt drop. 75 millivolt drop should force this meter full scale. So I played around with some type 80 nichrome wire, 16, 18, and 20. Here's the ohms per foot. And here's the ohms per inch. And I need 0.075 ohms. 1 inch of this will give us 0.0529 ohms, which I think is 1.5 inches. Now, to be fair, this calculation neglects the fact that some of the current will be flowing through the meter. This calculation says all 1 amp is flowing through the wire. So I want 1.5 inches of this 20 wire. It's supposed to have been annealed, but it's going to be very stiff. See what I mean? It's going to be very hard to cut. Okay. By the way, this is a chart of, it covers both 60 and 80 nichrome. There it is by gauge. The outside diameter of the wire won't change with 60 or 80. The outside diameter is what the diameter of number 16 or number 18 or 20 is. And I have nichrome 80, so I have resistance for ohms. Resistance in ohms per foot, I'm using number 20, which is 0.63. Ohms per foot, which is what I used in my calculation here. What I intend to do is take off about 3 inches. Should be right there. I put a little black band the whole way around it, 1.5 inches apart. Here are the terminals on the meter. So I'm going to bend it right in the middle about there. I'm going to go find a mandrel. This is actually a 1/4 inch steel bar. For those of you that know these things, it's a 1/4 inch transfer punch. But to say it's 1/4 inch steel bar. Now this is going to be tough to do. I've wrapped it around. I made a spring sort of like this. And hopefully I'll be able to shrink or enlarge the spring. Now, when you're working with a resistance like 0.075 ohms, it's useless to use an ohm meter, at least the ones you and I can afford. I only did the calculation to see about how much nichrome wire I needed and to pick what gauge. Now I'm going to hook up a constant current power supply to the meter. I'm going to set that current at 0.5 amp. Okay, so that's 0.5 amp. You can see the meter reads a little bit low, a teeny tiny bit low. There's 0. Put 0.5 amp on it. And you see it's a tiny bit low. So if I want to raise that, move the needle up, I need to force more current through the meter movement. So at this point, I've compressed the coils to put more nichrome between the terminals. You see what it did? It caused the reading to increase. So I need to take it back a little bit. You can see how long this piece is here. What I'll do is loosen this nut up, expand this a little bit, and get a little less nichrome between the terminals. Just a tiny bit more, and I should be fine. And that looks about perfect. So I'll take my supply to 1 amp. And there we have it at 1 amp. Try 200 milliamps. And there we are at 200 milliamps. So that's how we can rescale a meter. Now, had there been no internal shunt, it would have been exactly the same way. Calculations may have been slightly different. Now, if I had bought a 0 to 5 amp meter, it would have been a little bit more awkward to rescale to 1 amp because I would have had to change the scale. So I bought a 0 to 10 amp meter, knowing that I wanted a 0 to 1 amp meter. Now I will take some red, I don't know, nail polish and mark these so they're not, if they move, I can identify that they've been tampered with. And I'll need to come up with another washer and nut because I have no more. I don't want to put the wire connection in with the shunt. I want it to be on top of the shunt. Normally, if you take out this piece of metal and you use very thin not bond, some thin paper. You can print the scale in a, like AutoCAD or whatever, and glue it on the scale and stick it back in without touching the needle. So that's how I'm going to rescale the 2 amp meters that I use on the tracking power supply.